it's working now. Maybe we can try. Do you hear me now? I assume you do hear me. For some reason, the my road NTG doesn't work. Let me just do one thing. Let me just add a filter here. Just a second. Noise suppression. Filters, add noise suppression. Okay. Hopefully this is good enough. Nice, let's get started. Technical report for makes a big difference. Is it much better? Better now? Okay. Much better, awesome. Okay. Technical report for Polyglot-Ko, open source large scale Korean language models. So Eleutherii basically has this Polyglot project, and they trained a couple of large language models for foreign languages, such as, when I say foreign, I mean non-English languages, such as Korean, Japanese, and I think Chinese folks also trained this Pangu model, like I think Huawei trained Pangu. So let's quickly go through this paper and see the results. Maybe we can quickly skim first. This is how I would usually read it. First, let's kind of read the abstract. So Polyglot is a pioneering project aimed at enhancing the non-English language performance of multilingual language models. Despite the availability of various multilingual models such as MBERT, XGLM, and Bloom, researchers and developers often resort to building monolingual models in their respective languages due to the dissatisfaction with the current multilingual models' non-English language capabilities. Addressing this gap, we seek to develop advanced multilingual language models that offer improved performance in non-English languages. In this paper, we introduced the polyglot Korean models, which represent a specific focus rather than being multilingual in nature. In collaboration with Tunip, which is some AI company based in South Korea, our team collected 1.2 terabytes of Korean data meticulously curated for our research journey. We made a deliberate decision to prioritize the development of Korean models before venturing into multilingual models. This choice was motivated by multiple factors. Firstly, the Korean models facilitated performance comparisons with existing multilingual models, and finally, they cater to the specific needs of Korean companies and researchers. This paper presents our work in developing the polyglot Korean models, which propose some steps towards addressing the non-English language performance gap in multilingual language models. Okay, let's see what are some of the high-level things we can kind of see here. So we can kind of see how the dataset was constructed. Mostly it's Korean blog posts, almost 700 gigabytes. And then we have some Korean news dataset, blah, blah, blah. And so all in total, this is less than 1.2 terabytes because this is, I assume, filtered. This is the filtered dataset. This is the raw. 1.2 terabytes is just the raw dataset. And then they have a couple of checkpoints as far as I can tell here. 1.3 billion, 3.8, 5.8 billion parameters. I already see stability given compute, 256 A100s, which means 32 nodes with 8 GPU each. Okay, and then there is also the 12.8 billion model. Here's the configuration for each of these checkpoints. They use rope. They've done a bunch of experiments on different, well, now I assume, I'm not sure how this looks like for Korean though. Is this a translation to Korean, or like, I'm not sure how that looks like. That's something we're gonna find out. Comparative results of the performance on the COPA and Hella Swag tasks. So here is this one, the model from this paper, and here are some baselines, Co-GPT, XGLM. Well, this one is bigger, so it's not really apple-to-apple comparison, but obviously outperforms them on these tasks, looking at the bold numbers. Similarly here, the red lines are this model, and then that's pretty much it. And then so it's going to be a fairly easy paper. Conclusion: currently, we are actively working on training the new version of the Polyglot Korean language model. Our aim is to expand its capacity to eventually reach 40 billion parameters. This process has involved significant trial and error as we strive to enhance the performance and capabilities of the model. Based on our experience and expertise in developing Korean language models, we have also embarked on the creation of two types of multilingual models. The first type is an East Asian model. So let me just see again. We have also embarked on creation of two types of multilingual, two types. The first type is East Asian model, which includes Korean, Chinese, Japanese, Indonesian, Malay, Vietnamese, Thai, and English. This model aims to cater to the linguistic needs of the countries in the East Asian region. The second type is a Romance model, which incorporates Spanish, Portuguese, French, Romanian, and Italian. This model is designed to support the linguistic requirements of Romance language-speaking countries. Okay? By developing these multilingual models, we aim to democratize and promote access to language model technology across the globe. We believe that this will contribute to the advancement of research and academics in various countries, allowing users to leverage the power of language models for diverse applications and linguistic contexts. We are excited about the potential impact and benefits these models can bring to researchers, practitioners, and language enthusiasts worldwide. Okay. Grateful for Stability AI for generously providing the essential computer resources. Appreciation to Tunib. They provided basically the Korean dataset. And Stella Biderman for her valuable feedback on the paper, which greatly enhanced the quality and clarity of our work. Let's skim through the abstract, through the story appendix, prompt modifications, results for some particular task, and some additional results here. Modify prompt left. Okay. So the red line is always the Polyglot-Ko, Polyglot Korean. Okay, now let's see some of the details behind the paper. Let's kind of skim through it. The advent of large-scale language models has revolutionized, blah, blah. This is going to be just standard boilerplate introduction pretty much. Let me just skim through it. We can all do it for ourselves. I can zoom in a little bit if it's better. Hi there, welcome. We're just skimming through the paper basically. I have already done a quick overview, so maybe you can go a bit back to a couple of minutes ago. Hi Stefan, pozdrav. We chose to prioritize the Korean language as the initial model because our founding members are primarily Korean, and we had a readily available dataset for training purposes. Eleutheri, okay, interesting. I didn't know that most of Eleutheri folks are Korean. Is that true? Because Stella Biderman, Aaron Komatsuzaki, all of them are they're definitely not Korean, I think. Okay, Nothing informative there. Let's just skim. Largest publicly available Korean language model suitable for commercial applications, making it invaluable resource for researchers and practitioners engaged in Korean NLP tasks. They use some Korean co-best benchmark to do the evals. Okay, let's go. Let's see the data set. So they collaborated with this company, Tunib, to collect a large-scale Korean language dataset for our research. So as I said, 1.2 terabytes, meticulously gathered through a collaborative effort. Subsequently, we performed pre-processing, resulting in 863 gigabytes that served as the foundation for our analysis and model training. And out of those, I think they use around 200. I think they use around 200 billion tokens. Let's see. Data analysis. Removing PII, personally identifiable information. Look at the 5.8b spec in table. What exactly? I'm not sure what you're referring to, like number of tokens? I don't see it. We're gonna get there in a second either way. By thoroughly analyzing the data, we strive to minimize these risks and ensure the robustness and privacy compliance of our models. Through a meticulous examination, blah, 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 we successfully categorize them into 4 distinct types. News and Wikipedia. Sufficiently long text sequences, okay. Data requiring contextual information for training. Blog data and news data. Numerous short texts that were incorrectly scraped, necessitating the inclusion of contextual information during the training process. Data containing hate speech, a significant presence of hate speech. Okay, and then task-specific data. This category encompasses data specifically designed for NLP tasks such as text classification or entity recognition. While this data can be utilized for model training, it necessitates separate handling during model evaluation. Okay, so during the examination of data types, we encountered various quality issues. And then they incorporated the knowledge into the processing pipeline. Empty text, instances with no text content, unnecessary spaces, identification and removal of PII, uncleaned HTML, deduplication, broken code, short text, excessively short data instances, repeated characters. I remember, I think when they were training Bloom, like there was this, they had issues with basically the model spiking, the loss spiking. And it turned out there was like a sequence of 1 million or something / characters in one of the data sets they collected. So this is, you can end up in interesting training dynamics if you don't handle some of these things like repeated characters. Just FYI. By addressing these quality issues, we aim to enhance our crucial aspect of our data processing was removal of HTML-like code to a large extent. Okay. Models. To train the polyglot models, they use the GPT-NeoX codebase, which we just started analyzing in the last stream. Provide a solid foundation for our training process. We receive invaluable assistance from Stability AI. As we said, 256 A100s played a crucial role in efficiently training the models. The training tokens information for each model is as follows. So you can see here around 200 billion tokens. I was right. So they're probably increasing the number of tokens a little bit for bigger models, hopefully. Actually not. Interesting. So they train the bigger models on less data. That's definitely not optimal. You want to maybe even overtrain them, not like I think equally sized lemma checkpoints where models were trained on like trillion tokens or something, if not more. Due to the limitations of available computational resources, the models were trained with varying numbers of tokens. Okay. Despite our efforts, we suspect it was overtrained or overfitting. Okay. Broken generation occurred as the loss sharply dropped near the first epoch boundary for the smaller models. Consequently, we made the decision to select and early stop the model checkpoints prior to the epoch boundary as they exhibited better generation performance. Interesting. A consistent tokenizer was utilized across all models, featuring a vocab size of 30,000. Trained using morpheme-aware BPE, byte-level BPE. We performed morpheme analysis using McCab. Isn't this for Japanese? Let me see. So, McCab, a widely used morphological analysis tool for Korean text. This ensured that the model were equipped with an effective and consistent tokenization scheme tailored for the Korean language. Now let's delve into the details of each model's training process. Without model parallelism, total batch size of 1024, broken generation around 100,000 steps, model checkpoints were evaluated and verified prior to the onset of it to ensure optimal model selection. Same symptoms around 100K. Applied the model parallelism, remained the same as that of the previous checkpoint. As a result, the decision was made to halt the model training process. Okay. The 5.8 billion utilized model parallelism, and the overall batch was reduced by 1/4 size of the previous models. We trained with 172 billion tokens, which consisted of a total of 320,000 steps. Okay, so more steps because I guess memory issues or whatnot. I'm not sure what's the reasoning behind reducing batch size, reducing number of tokens, and then increasing the number of steps, thus the wall clock. Okay. As it was trained with lower tokens compared to the previous smaller checkpoints, the performance consistently improved as the number of training steps increased. Surprise, surprise. And then the final model, they've done some gradient accumulation steps and trained for a total of 300K steps. Okay, fair enough. And then there is a configuration for these models. Okay. And let's see the experiments. Have we missed anything here? I don't think so. We've seen everything. Maybe just skim. Let's quickly skim whether there is something interesting here. Clova. Okay, nothing super insightful. Let's see the experiments. We conducted an evaluation of Polyglot-Ko on the Ko-best dataset, okay, which encompasses 5 downstream tasks: Copa, HelaSwag, blah blah blah. Each task focuses on different aspects of language understanding and reasoning. Copa, selection of alternative that is a cause effect of a given premise. HelaSwag, common sense reasoning. Bull-Q, reasoning over multiple sentences. Senti-neg, sentiment analysis in the Korean language. WIC, identifying whether the meaning of a target word is the same or different in 2 given contexts. Okay. During the eval, we compared the performance of Polyglot with other similar models, including the Ko GPT Trinity 1.2b, CodeGPT, XGLM. These models were chosen as they are currently the only publicly available billion-scale Korean language models, excluding other multilingual models. The evaluation process involved using the provided prompts, and F1 scores were used as the eval metric. We utilized the Polyglot branch of Eleuther AI's LLM eval harness repo, which provided the evaluation codebase for our experiments. This allowed for consistent and standardized eval procedures across the models, ensuring fair comparison. Not to report the performance of Polyglot on WIC in this section due to nearly random performance observed across all models. Okay, however, detailed results for the VIC can be found in appendix. Figure 1 illustrates the results obtained when varying the number of few-shot examples. Okay, let's see COPA. Just grab some water. Okay, the experiment was conducted on the COPA task. And the results are presented in the left portion of table 3. Okay. Comprehensive comparison to ensure fairness. All were evaluated under the same conditions. Outperforms all of the other models. Okay. They just basically say the model is better. Okay, and same goes for all of the tasks pretty much, as far as I can tell. Okay. Hello swag. Let's see whether there is anything interesting that's not just saying, hey, we are better. Is there any additional insight? The table includes the model name. However, in the zero-shot scenario, Kakao Brain's CodeGPT model achieves the high score. Okay, that's interesting. In zero-shot, Kakao Brain is better, although that model is like much smaller. Let me see. CodeGPT, zero-shot. Why did they then bold? Why is this number bolded if this is bigger? No. I'm not sure what's going on there. Okay, bool Q. Nothing informative there as well. And then the final one is this one, Sentineg. Facebook's models was consistently the worst one. Modified prompt. When analyzing the performance of Polyglot model only in the 5-shot evaluation across all 4 tasks, it becomes clear that the performance improves with increasing compute, as depicted in figure 2. Okay, let's see. Okay, surprise, surprise. Compute, I guess, is for training bigger models. Okay, makes sense. Limitations and disclaimers. zero information here. Each paper literally says the same thing in the introduction and in these limitations and disclaimers. I never saw bigger checkpoints of polyglot model coming out. Like, might be a good thing to just reach out to the authors and ask them what's going on, because this is something that interests me deeply. Maybe not Korean per se, but like I would love to train for some European languages, including Serbian, which I could debug because I speak the language. Furthermore, we discovered mistakes in the data processing phase during our experiments. The data was incorrectly stripped of new lines, leading to a loss of document structure. This likely resulted in some information loss during the model training process. It is important to address this issue in future iterations to ensure the preservation of document structure and minimize information loss. These considerations highlight the importance of continuously improving the training process and addressing any limitations or errors that arise. By doing so, we can enhance the performance and reliability of Polyglot-Ko for a wide range of tasks and applications. Okay, guys, nothing really super insightful. It would be super cool if they had a section describing exactly how they collected the data, but I assume that this startup is basically just definitely doesn't have any incentives to do that. So, Tunib. Cool. We've read this one. Do you guys have any question? Let me know if you have any questions. Let me just check mark this one. Adi, I'm gonna reply to your question in a second. Just give me a second. Hey Asim, what's up, man? We just went through the paper actually, so maybe you can rewatch this part. I went through the polyglot Korean language, large language model for Korean language from Ulu3i, folks. Let me just also write. And now we're going to go through the Japanese language model. So, questions. In the 5.8 billion spec, let me just read this. Is there a reason why N layers and N heads don't seem to follow the ascending trend? Going from... Okay, let's see that for a second. Just give me a second. Well, they did increase other, right? They increased the internal model dimension as well as the DFF, which is the layer that's like the hidden layer for the MLP in the transformer block, and more heads as well. So they they probably have done some ablations. Ultimately, just boils down to some experiments. I don't think it's not exact science, right? You have to experiment and see what works. They probably didn't have enough compute, by the way, to find optimal parameters. It's just who knows how they've done it. It would be super cool if they kind of shared some of the struggles while training the model. I'm not sure. I've never seen any such report with GPT-NeoX. Okay, guys. Give me a second and we can go through this. Japanese stable large model marking entry into international language model market on 10th of August. No worries. Okay. Today, Stability AI released its first Japanese language model, Japanese Stable LM Alpha, the best performing openly available LM created for Japanese speakers. 7 billion parameter general purpose language model, it stands as the top performing publicly available Japanese language model according to a benchmark suit against 4 sets of other Japanese LMs. Will be released under the commercially available Apache Tool license. Okay. And then you also have instruct tuned version exclusively for research use. Please refer to Hugging Face page. Let's check out those two. We are proud of our first blog, a big step towards contributing to the Japanese generative AI ecosystem, said Meng Li, project lead. We look forward to continuing to create models across several modalities, but specifically to reflect Japanese culture, language, and aesthetics. Okay. Is this the same model as what we already opened? I think it is. Yeah. It was trained for text generation using large-scale data sourced mainly from the web, predominantly composed of Japanese and English text, with the remaining 2% of material in the form of source code. In addition to open datasets, the training data includes datasets created by Stability AI Japan and datasets created with a cooperation of the Japanese team of the Luther AI Polyglot project, along with members of Stability AI Japan's community. Okay. So multiple sources. So open datasets, Stability AI Japan, community, Luther AI. Okay. For training, we use software that is an extension of Luther AI's GPT-NeoX. For example, the model architecture incorporates new technologies such as Swiglu and XPOS. This is, I guess, one of the new encoding methods. A cumulative total of 750 billion tokens were processed across epochs. Okay. Additionally, tuned to follow user instructions. Supervised fine-tuning was employed. Significantly improves the performance evaluation score by LM eval hardness. Okay. Performance evaluation. Let's see the results here. There are some bilingual models they're comparing against. Japanese GPT-NeoX. Okay. Similarly to the conventions in the OpenLLM leaderboard, the average of the scores in the A task is calculated and used for the overall evaluation of each model. The instruct model scored 54.71, which places it far ahead of other Japanese models. Okay. Sounds good. Let's skim the model cards, see whether there is something interesting here. Any questions here, guys, by the way? A parrot able to speak Japanese. Uki Edo period. Here are some data sets they use. Japanese, Oscar. Red pajama as well. Oh, interesting. Isn't that English data set mostly? They're using the V1 version of Novel AI Tokenizer. Who are these guys? Because it processes both Japanese and English text effectively and efficiently. We extend our gratitude to Novel AI for allowing us to use their remarkable work. For more details about the tokenizer, please refer to their blog post. Grateful to contributions of the Eleutheria Polyglot Japan team. Okay. Nice. Cool. Do multilingual language models use the same tokenizer for all the languages they support? Mainly interested to know how it affects number of tokens per character and its relation to inference training cost. Yes, I think they mostly use the same tokenizer. I know that NLLB project also uses the same tokenizer for all 200 plus languages, 202 languages, always the same tokenizer. It's just that you increase the vocab size from, I don't know, like 30, 50,000 to, I think that NLLB used 250 something thousand tokens. Let me just quickly skim and see what this tokenizer is about. What's so special? Why couldn't they just train a new tokenizer themselves? Okay, just reading a little bit about this, nothing insightful so far. Well, not really, right? I mean, it depends how it really depends how good it is for your target language, right? It can still be for that particular language. You can still have fairly like small number of tokens when you tokenize your sentence in target language, and you can still have short context length. So it depends. But usually English is going to be, if you have multilingual, it depends on what are the percentages of your data sets. English usually has the most data, obviously, and so usually the context length is going to be the shortest for English. but it really depends on the composition of your data set. The most common implementation of BPE is probably the GPT-2 one. Google's sentence piece implementation of BPE offers the not so slight advantage of natively being able to tokenize Unicode characters directly without having to assemble them from bytes, which requires additional tokens representing partial Unicode code points to be added to the vocab, wasting some additional space. Okay. Finally, the compression ratio achieved by the tokenizer is important to consider. We more easily achieve a dataset of a given size. Okay. If your tokenizer compresses text less efficiently, you may more easily achieve a dataset of a given size, but it stands to reason that a model trained on such a less efficiently tokenized dataset of a given size will learn less than one trained on the same size dataset that was tokenized with a tokenizer that achieves a higher compression ratio because, in effect, it will see fewer bits of factual information during training. Okay, with all these things in mind, we decided that we want our own tokenizer for the models we will train that is better optimized for our use cases such as storytelling. Okay, so both Hugging Face's Tokenizers library and Google Sentence Piece support training tokenizer of different types. Sentence Piece is more memory efficient, although a training dataset in the low double-digit gigabytes still required a compute node. With 1 terabyte of RAM to run successfully. Wow. Due to this, we decided to use Sentence Piece. Interesting. What makes it eat so much memory? 1 terabyte of RAM. God. Number of tokens for Hindi is 3 or 4x English in the model I trained. I guess Hindi content is very little in Llama 2. Maybe that is the reason. Highly likely. You can probably open up the paper and see. I'm not sure whether they shared the composition, how many languages they were, what's the kind of split between different languages. But I would assume that Hindi is definitely much less. I think Llama 2 is almost exclusively only English. Llama 2 paper. Let's open it up. I'm fairly sure it's pretty much English only. Pre-training data. Okay, it says here, consequently, the model's performance in languages other than English remains fragile and should be used with caution. Table 10. So mostly English, then German, then French. So like Hindi is probably below, who knows. Hindi is, I think, HI, right? That's the code for Hindi. Hindi is not even here. This is Korean. Hindi is not even on the chart. So Hindi is like super low percentage. No, it's probably there, but it's just in this unknown category where they've lumped all of the languages. We found that modifying an existing tokenizer to support an additional language was not a pleasant experience, as it seems likely that we will want to do similar language transfer learning in the future. We have decided to have our tokenizer accommodate both English and Japanese from the start. For this reason, we decided to double the vocab size to 64,000. Okay, so they went all the way to 65K. Yep. Here is the link. This is just a tokenizer that was mentioned on the Stability AI blog about the Japanese large language model. Just hopping in, if they use transformers, do you think grammar would influence different languages' tokenization processes? I don't think tokenizers care about grammar. They care about how much text you have. The more text you have, the more the algorithm can learn how to compress your tokens, your words. We have manually added tokens for certain multi-white space strings. Okay. Taking nearly a whole day. Okay. Nice. They literally have higher compression ratio than Llama's tokenizer. Interesting. No Japanese token longer than a single character. So that's the reason why if you were to tokenize Japanese text using Llama's tokenizer, you would end up having very, very large context length. Okay. Nice. We've added BPE Sentence Support along with a novel AI. And what's Nerd Stash? Vocab. Okay, just a huge license. Training dataset. Let me see the data they used. Let me just skim this. Japanese translation of the Stanford alpaca data set. How do they translate the data set? That's something I'm curious about. They use ChatGPT API to translate to Japanese. ChatGPT is not that good for translation. They should have probably used DeepL or something. DeepL is much better. DeepL supported languages. I think they support, I'm fairly sure they support Japanese. Yeah, they support Japanese. This is probably way better than than ChatGPT. I read some papers about how good ChatGPT and GPT-4 and Palm are for translation, even when you prompt them, and they are very good, but they are not as good as the best commercial translators. Just FYI. Okay. Let's now continue playing with GPT-NeoX. And let me ping somebody from the Luther AI community to ask them about the Polyglot project. Let me just quickly send the message. Okay. I pinged one of my friends from Luther AI, actually Aaron. Do you think training a new tokenizer on Hindi, English, or any two languages, plus fine-tuning a lemma on dataset of the other language be effective at all? Confused a bit here. I mean, you can't, once you've trained the model with a tokenizer, you can't really just use you would have to retrain the model basically, because the model doesn't know how to use your tokenizer, right? You would completely mess up the distribution of vectors that the model sees. It wouldn't be able to generalize. Okay, let me just think here. Plan for the next steps. Okay. Let me quickly stretch my legs, get some water, and we can then start playing with GPT-NeoX codebase. We got it set up in the previous stream. Fairly easy following the README to just set it up. And we get some gibberish text from the generate script because I didn't download any checkpoints. So I'm not sure what's actually it's using some weights in the background, probably just some random weights, although it doesn't seem completely random, so I'm not sure what happened here. We're going to debug that. I'm just using the 125 million parameter model. And yeah, we can go and do step-by-step analysis of this script to just get a bit more understanding of the code base. And then we can try a couple of these other ones. There's a couple more high-level scripts that we can use, like train and then prepare data and evaluate. Let me go grab some water. I'll be back in a couple of minutes, guys. Okay, guys, I'm back. You could initialize the initial English embeddings to the pre-trained lemma ones, and then just extend the vocab with the Hindi tokens. Yeah, I don't know. I'm not sure. I don't know enough details about lemma's tokenizer, to be honest. Is it only... Wait. I don't even know the size. If it's like 30-something thousand tokens. Not completely sure, guys. Okay. Yeah. Okay. Let's run this. Let's put a breakpoint here. I want to understand a bit better what's going on here. So again, for context, for those of you who were not here before, I've set arguments here for the script. We're going to run the generate script, which basically, as the name suggests, just us. We just sample from the model. We passed in the config file for the 125 million parameter model, local setup, and text generation YAML files just contain some sampling configs, and this contains information about where the vocab is and a couple of other things. but that's it in a nutshell. So now I have a checkpoint here. Let's just run this script. So this is their main entry script for all of for training, fine-tuning, generation, everything really. So let's run it. Let's hit the breakpoint in generate, and then let's start there. So we can see there's some, let me see what, it's just printing out a bunch of stuff here. Is there anything interesting here? Number of GPUs is 2. A ton of config settings, and then number of nodes 1. Okay, world size 2. Setting CUDA visible to 0, 1. Okay, let's now enter this function here, and let's see what's going on. Setup for inference or eval, and that function gives us back, I guess, model object and the arguments. So it does parsing, and this is kind of weird abstraction, right? Single line returning the arguments, parsing the arguments, and giving you back the model object. Let's enter some imports here. What's going on? Okay, we might be, yeah, we basically have 2 processes. So that might be confusing. Let's just make sure. Okay, good. Consume NeoX arguments. Overwrite values. Why are we overwriting this? Looks very hacky. Zero optimization, none. Okay. Let's quickly see what's going on here. Deep speed launcher needs to pass the arguments for pre-trained GPT-2 across to all machines in order to not have any problems with different configs being mismatched across machines. We instead read the YAML configuration file from the main rank, then serialize the arguments to a dictionary which the deep speed launcher broadcasts to all machines. We then instantiate a new NeoX args from the dictionary. This should ensure arguments are never inconsistent across machines. Okay, some logic to make sure that we have consistency of input arguments. Let's see, Megatron config, deep speed config, parse the known arguments, load string. What's this? Megatron config. Why is this gibberish? I guess it's just, yeah, okay, it's base 64. Did we actually pass this ourselves? I don't think we did. So we decode that and we get something. Okay, Megatron. Okay, let's go. Set up auto tuning. Update the config with the override values, and then create a class NeoX args from Megatron config. And that does what? Okay. So we are back to the setup for inference revolve. Configure distributed arguments. Are we using slurm? No, we are not. Local rank. If rank 0, we can just print, and we print indeed. So we get using role size 2 and model parallel size 1. And then we build the tokenizer. Whoops. I've accidentally clicked F5. Let me just quickly rerun the whole thing. Sorry about this. Let me just rerun it quickly, go back to where we stopped. Okay, we stopped here. Okay. Again, this was, okay, we saw that before. Build the tokenizer. NeoX arguments. Build the tokenizers. So which type of a tokenizer are we? We are GPT-2 BPE tokenizer. So that means this one. So assert that we have passed these two. Okay, we did. And then we just initialize the tokenizer. Okay, we don't have to go into the actual tokenizer. And then finally, vocab size with padding. Okay. So we keep on increasing until we get the size that's divisible by 128. I guess this has to do with the performance issues. So you might have seen Karpati suites where when you just add a couple of additional dimensions to like vocab or whatnot, or just like internal model dimension, you can completely pick a different kernel path and end up running a much more optimal kernel on the GPU. By the way, kernel just stands for a function that runs on GPU. Okay, return tokenizer. Initialize the weights and biases. Initialize Megatron. Let's see what's up there. After this is available, that GPU is available. Potentially load fused kernels. We don't need to do that because both of these are false. Scaled masked softmax fusion. Scaled upper triangular masked softmax fusion. Finish MPU init. Initialize distributed. Initializing torch distributed. This device number 0. And then we just set device. And then we call deep speed. Okay. So deep speed with an NCCL backend. I assume this is already actual deep speed library, right? Deep speed team, yes. This is a separate package. We're not gonna go into it. Okay. And then let's just go here again. This is the second process. Let me just come back to this line and then okay. Set up 3D topology. We are not bigger than 1, so this is gonna keep. We're gonna keep this one at 1, and then model parallelism also 1 because we have a fairly small model. We don't need neither model nor pipeline parallelism, basically. And then the world size is going to be 2, right? Pipeline model data, okay. This is from DeepSpeed. This does pipe one the most outside, then data, then model. Just a wrapper around over process topology that predefines this order, okay? Offset base seeds for the interior pipeline. Get coordinates. Okay, we don't have to dig too much deeply into this on the first pass. Initialize model parallel. This is going to be 1. Okay, let's just quickly see what this is. Again, this is Megatron library, right? Or no, this is under, this is some modification from Eleuther AI under the Megatron directory. It's not the actual different package. Let's quickly see what this is. World size, ensure divisibility, get the rank, topology, assert that this is none. Okay, and now that thing triggered the other process to start running. So let's go here. Let's quickly go here and then get to here. Frank 0. No worries. Welcome, Emrit. We went through the paper before. We went through the Korean large language model paper from Eleuther AI folks, and then we went through the Japanese large language model blog from Stability AI, and now we're just kind of digging a bit deeper into the generate script. And now I'm deeply into this distributed setup code. Or you can skip most of these. Let's just kind of quickly skim over this. This is not that important. We can just skip over all of this. Okay. Let's just skip. Or actually, no, let me quickly see what's going on. I do want to roughly see the code path we're taking. Okay. Okay, we're done, guys. We were here and then set up deep speed, random and activation checkpointing. Just see what it is. Optional deep speed activation. Configure, we can skip that one. Let's just exit. Set up model and optimizer. Here are the arguments. Iteration. Set a model and optimizer. Let's quickly see what this is. get the model. Again, I still feel this is super weird abstraction. Let's see. Get model. Building the GPT-2 model. You can skip most of this. Deep speed handles CUDA, blah, blah, blah. So the model ended up being what? GPT-2 model pipe. This is what we ended up with. GPT-2 model pipe, and this is, just quickly skim this, but I think I've seen this before. The largest change is flattening the GPT-2 model class, so we can express it as a sequence of layers, including embedding, transformer layers, and output. Okay, fair enough. Let's exit. Get the optimizer. Get the learning rate. If we're not loading, we go here and then initialize. Model optimizer. Okay. Again, we're just running the second process. That's why we're seeing duplicated code path. We can skip all of this. Get total parameters. Okay, that's the 150 million parameter model. So kind of makes sense. Is pipe parallel? This should not be pipe parallel. We have a single, we don't have multiple shards, if that's the terminology. Set batch function. If load is not none, okay, it's not none, then we load. Okay, this is where we might end up figuring out why we are having gibberish output. This is where the loading of the checkpoint happens. We can basically remove all breakpoints except for here, because this is the only thing we really care about here. Load the checkpoint. Again, load the checkpoint. Let's go here. Load false, false, true because of not. And tag. Which tag are we using? Okay. So how does it know where to load? Aha, okay, got it. I think it's just going to assume it's going to look for checkpoints directory in the root of the GPT-NeoX codebase, which we don't have currently. And then underneath, it's going to look for the latest checkpoint. That's what the README said. So that means we have to download the checkpoint somewhere before we run this. Let's see. So we are now inside of this function. If tag is none, Then latest tag is latest, as I said, and then this is the latest path, checkpoints latest. And if the path exists, which it doesn't, otherwise we basically say unable to find latest file there. If trying to load latest checkpoint, please ensure this file exists or pass an explicit checkpoint tag when loading a checkpoint. Fair enough. Unable to load the checkpoint. And then we just retrieve back the model. Inference mode. Setting the parallel output of the final layer to false, so logits are gathered across model parallel ranks. Okay. Fair enough. Okay, so let's see, how do we find checkpoints for some of these models? Not sure. Let's see whether somebody addressed this in the issues or something. Is there any other documentation that might be interesting to read here? Prepare, README, license, Docker file, tools, tests, requirements, Megatron eval, configs. Is there anything here? Pythia, README. Are there any checkpoints here? I don't think so. Okay, let's open up the issues. Checkpoints. What's the exact issue you're going through? I joined late, so maybe something trivial I'm asking. No, it's fine. I'm just trying to find a place where we download the actual models. I'm looking for the 350 million GPT-NeoX checkpoint, basically. I'm not sure whether we maybe have to ask them because they said that in the main README here. Let me show you. Checkpoints. We additionally have 150 checkpoints saved throughout training, one every 1,000 steps. We're working on figuring out how best to serve these at scale. But in the meanwhile, people interested in working with the partially trained checkpoints can email us. So they have, I think they have the 20B, you can download it from the Hugging Face hub, but I don't see the smaller ones. I'm just trying to figure out what's the best way to download and just start playing with some of those smaller models. if that makes sense. Let me just quickly skim through the issues. This is, by the way, my 10th hour of streaming today, so my brain is getting slowly wasted. God damn it. Okay, model is generating random strings. I think that might be related to what we are experiencing. Probably the same issue. Getting gibberish. Okay. Gibberish. Running on a single GPU. Importing checkpoints to transformer library. Inference with that 2.5 billion. All of those seem potentially promising. Okay, that's it. Let's see whether there's something interesting here. Okay, not really informative. Try merging the checkpoints as described for single GPU. Merge. What's this? Probably not something that's relevant. Okay, nothing happened helpful there. Getting gibberish. For A100 GPUs. Maybe we can just ping them in the server as well. In the GPT-NeoX server. Sorry, in the Eleutheri server. Yeah, I didn't find any solution there. Where are... Okay, we don't really even care. We don't... If we can't find it, that's fine. We can just analyze, even if it's gibberish, it doesn't matter. I'm just trying to get some familiarity with the code base, honestly. Nothing else. So it doesn't really matter. They only have the 20B checkpoint, basically. Let me ping them somewhere. Okay, let me just go to Eleutheri server, GPT-NeoX. I guess that's the only channel there. Let's see where we get an answer a bit later. Okay. Anyhow, let's continue with stepping through the code base. Let's keep on going here. Let's get inside of this function. And then generate samples from prompt. blah, blah, blah. It's interesting that we get results that are not completely gibberish if it's just randomly initialized. That's the weird part. I'm not sure how it even works. Huh. So this is unconditional, and that's why we have empty strings here. Okay. Context tokens, end of sentence token ID, and then length, context length. What did you find, Amrit? If you're sending a link, maybe better send it to Discord, because we noticed that here in YouTube Live, they might be like filtering out your URLs if you're sending any links. The last message I have from you is got it and then found this, and nothing else. Just FYI. Sequence length. Okay. All good there. Pythia scaling suit. Oh, good point. Yeah, we can maybe use, I'm not sure whether they can be used with these same configs. But good point, good point. I forgot about that completely, yes. I even read the paper like a week ago. Completely forgot about that. Yeah. Good point. Okay, we can try that. Stream tokens. Let me try. Let's quickly first run through this, and then we're gonna check out Pythia. Okay. Add. Context tokens. 2048. Why do we have 2048 here? Get batch. And then at one point we start computing. Okay. Move to GPU. Generate batch from context tokens. Attention mask and position IDs are created. Returned tensors will be on CUDA. LTOR masks and position IDs. Left to right model. Attention mask. Position IDs. This is probably just causal mask or something. Okay. batch size 1. Sequence length. Generation logits, maximum tokens, and then vocab size. Okay. And then while token index to generate is smaller than the last token index to generate, we keep on iterating here. And then ultimately we yield tokens to use, positions to use, and attention mask. And then we just do a forward pass. Here's the model inputs is pipe parallel. Let's quickly see what it does. We add deep speed pipeline only accepts iterables. Deep speed pipeline requires that you pass in labels for the loss. Okay. Turn off the AC. Okay. Micro batches sense metadata. Okay. Eval batch. So this is going to do the forward pass. Let me quickly see, just curious how much GPU, what's the GPU consumption here? Oh my God. Okay, around 1 gigabyte, because my baseline is around 2 gigabytes on this GPU here. Let's do a forward pass here. Okay, and then this guy, because we have 2. Let's just quickly run this. Okay, forward just gave us back the logits. Fair enough. If it's not none, then we just grab, I guess, the last token, -1. And that's going to be vocab size. Filtering, softmax. State started. Switch out pairing tokens. Thanks, Adam. Thanks, man. Appreciate it. Okay. State done. We are not done because the generated token is not equal to end of sentence token. It is done. Stop tokens produced. Okay, and then we just yield the context tokens. Okay, and then we just keep on iterating there. So let's exit. After the generation. Shift F11 to exit. It's running. Stream tokens, I expect us to stop here. It's running 10 different sampling sequences. Okay, is it done? I think it just ended. Okay, let's disable basically all breakpoints except for this one. And let me just quickly rerun this. Let's see what happens there. Okay, here we are. Okay, and then it's just basically returning back a dictionary with the generated text, which is gibberish, as you can see, but still there is some structure, which makes me think, is it just by the very fact that this, I don't know, like, if you just have random weights, there is no way you can get such a coherent, something that looks like words, even though it's gibberish. There is some structure to it, right? That's the part that's confusing me. How is it even giving us this amount of structure in the generation? That's not something I would expect. And then we just retrieve that back, and that's it. Okay. We are done. Okay, exited successfully. Okay, so there is a ton of details because they are using Megatron, they're using deep speed. I even found Fairsec maybe a bit more intuitive once you get deeper into the framework. Interesting. Let's see how active it is. GPT-NeoX, GitHub. Just curious about the activity in the repo. Five days ago, 2 weeks ago, 3 weeks ago, July. People are definitely working on it. Okay, what else? Let's see a couple of other high-level scripts we could run. Yeah, NeoX is definitely very active. We've done the generate script. Let's skim through the eval script, and let's skim long stream today. Yeah, 11 hours, man. just experimenting a little bit to see how much I can do it. Evaluate, and then let me check out prepared data, and let me check out train.py. By the way, here is the output from the previous program. It gives us 10 different sequences which are not completely gibberish, but obviously not proper English or any language really. So that's really fun. Why? Could it be that if you just have deep enough neural network and random weights and you propagate whatever signal, you're going to end up with human language? Everything converges towards human language. That that would explain the intelligence, biological intelligence in humans. You just need big enough neural network. But then you would expect elephants to be smarter than us, which is obviously not the case, to the best of human knowledge at least. Language is all you need, yeah. Big neural network is all you need. Language is a second order consequence. Okay, train, eval, and prepare. Let's kind of skim through these. Prepare data. Maybe that can be one we can play with. What does it do? Elephants will converge to human language. Maybe. Maybe they already speak the human language just in different modality, using some undiscovered signal. Telepathy. Elephantity. That's a bad joke. Hate the downloaders. Let's see, what's this? Okay, they have for different types of data sets, different ways to download them. This looks like a distribution of components like pile. And that probably is the same code they use to download pile. Okay, DI pile preliminary components. Okay, yeah, it's definitely pile. Okay. Get args. Let's try and run this. Let's see how they run the prepared data. I saw something in the README. Okay. Prepare data. Okay. A couple of examples here. Okay, can use something like this. So we basically just call prepare data, and we say we just point it to the right directory or a single shard of the file with the GPT-NeoX when it be tokenizer by doing this. You save to 2 files, and you will need to add the prefix that both these files share to your training configuration file under the data path. Okay. Let's just run this. The first line looks the simplest one. We already have GPT-2 tokenizer downloaded. We don't have to play with 20V tokenizer. Okay, let's try this. Let's go to prepare prepare data. Let's find the launch. Yep, the launch JSON file. Let's just copy and create one more config. So this one is going to be prepare data, and then the data, and then just delete everything else. Okay, looking good. Actually, just a second. Do we directly call prepare data, or do we go via dpy again? Let me just double check that. README prepare data. No, we are not. We're just analyzing the code base because it's one of the better code bases if you want to train bigger models. Although they've never trained machine translation models to the best of my knowledge, so that means we'll have to do some modifications on top of it. I'm going to consult with some of the Eleuther.ai folks and ask them for some advice. Okay, so we directly call the Python prepare data. Makes sense. That means we have to go here and remove this, and we just go okay, and let's just go and run sorry about that, guys. Prepare data, where is it? Okay, here it is. Let's run it. Okay, here we are. Arguments, so the default is going to be NVK. How big is this dataset, by the way? What's the size of this one? MB of English Wikipedia XML dump on March 3rd, 2006. Okay. English Wikipedia. Makes sense. Tokenizer GPT-2 by default. And then data, vocab, and merge file. It's probably going to assume default location, and that's the location where we save those. I think that was under here those two. And then force re-download. Default is false. Okay, prepare dataset. Let's see what happens here. Let's run this. Okay. Maybe download GPT-2 tokenizer data. I don't think we will have to do that because it already exists. If it doesn't exist, then we would go and call system vget blah blah blah. Okay. So data downloaders. We grab the NVK downloader, and then there is a downloader class which does, okay, let's just run this and see whether we end up in the init file. Okay, init function, sorry. Brain 404. Okay, and then prepare. If it doesn't exist, then we download first and then we tokenize. So again, base directory, and then inside of it we create name. So that means we're gonna end up with a directory here, and then for all of the URLs, and there is a single one, we just call the wget, and then we just run that. Okay, 100 megabytes shouldn't take too long, especially because I literally have optic fiber directly wired into my rig. And then tokenize. Let's see what the tokenizer does. Here it is. Here is the path. And then we call the pre-processed data script. Okay, so what I would love to do now is, instead of calling this like this, I would love to just dump the arguments and call the script myself, because I want to step through it, right? I don't know why they insist so much on calling OS system instead of just running the thing directly. Why not call the pre-processed data function or the function from that file and just run whatever you want? I don't know. What's the advantage? I'm not sure. Okay, so let's dump the CMD value here. Debug console, CMD, here it is. Let's take this. Let's copy it. Let's open up the launch JSON again. Okay. Let's create yet another config. And let's call that pre-process data. And then let's just quickly copy paste all of these. We might have to plug in the absolute paths there, but let's take it step by step. Memory map, tokenizer type, GPT-2. Exactly. Maybe we can just use Copilot, man. That's one of the best things about Copilot. Why didn't it offer me the solution earlier? Workers, nice. That's the power of Copilot, man. One of the best things ever. Once we start coding more, that's going to shine even more. Okay, I think we're good there. So now if we call the Python tools pre-process data script, so let's see where it is. Where is this file, namely? I'm not sure. Aha, Python tool in the tools. Okay. Tools directory. It should be somewhere here. Pre-processed data, right? Yep. So we're going to call this one directly. But I think we need to add a prefix here. So let's just do one thing. Let's just do copy path here. And instead of data, let's just put it like this. Expand. Let's just expand the whole thing. Let's just expand it. And let's just expand this one. Okay, should be good. Now let's run the pre-processed data. Let's stop the current execution, because after we are done with this, we basically are done, because that's the last call here in the prepare dataset function. I'm gonna stop that, and I'm gonna just call pre-process data directly. Let's go to main. Let's just be here, and then select the config, pre-process, run, and we're literally gonna do the same thing, just this time we can actually step through instead of holding it via the operating system function. Okay. Get arguments. And then we create some encoder. An encoder is, I guess, what? Tokenizer. Okay. It's just an object that builds the tokenizer. Inside of Megatron, there is tokenizer. Fair enough. Let's go. Why do you call build tokenizer if this guy already called build tokenizer inside of it? Okay. That seems redundant, right? Building the GPT-2 tokenizer, padded with 47 dummy tokens so that the new size is 50,304. Output prefix, semaphore. Build a semaphore object to stop yield from files from getting ahead of encoder encode and hence building up memory. They never called build tokenizer for the encoder, did they not? Initializer, wait. Where is this function called? Maybe you're right, but then why just not call the initializer on the encoder class as opposed to directly calling it here? I kind of assume that they're somehow implicitly calling that function, but you're right. It's just inheriting from a simple object, so nothing is happening here, right? This is just Python object. Yeah. Built in. Okay, build a semaphore object to stop yield from files from getting ahead of encoder encode and hence building up memory. And then you pass in 10,001. Why 10,001? Magic. And it's implemented inside threading. Okay, this is just the threading standard library semaphore object. Okay, as vanilla as it gets. And then we call yield from files. And this is going to be the input, and we split and we pass in the semaphore as well. Okay, and then that's going to be the probably some generator that we're going to call here. Aha, so the initializer is called here. It's passed as the initializer. Huh. Probably because each of the processes inside of the pool has to have access to a particular tokenizer, right? That's why they're doing that. And then they pass the encode here to IMAP and the file as well, chunk size. Aha, but that's only if we have more than one and we have a single. So we're gonna go this direction actually. So yeah, they did call tokenizer again after all, right? So this one and this line are doing the same thing. a little bit of banana, snacks, keeping that sugar level. Yield from files. Iterator over input documents using LLM data format. Should be able to handle JSON, text, and other compressed formats. Also filters out empty documents. Okay, so we iterate through the file names. And then each time we acquire a semaphore, and then we call yield from yielder. So it's just a generator, as I assumed. Really, they never called it. They did to print out the vocab size, and then here as well. But yeah, definitely not the best use of resources, especially because it literally builds a, I don't know, it might, I'm not sure what's the memory profile, but anyhow. Again, here we're gonna call build tokenizer again. And then we start now iterating through the document, and we call the encode. We set the breakpoint here, and let's set a breakpoint here if we didn't already. I think we did. So let's go. Wait, is this just, yeah, okay, this is just lazy. Again, it didn't execute right there. It's going to execute a bit later. So JSON L keys, text. Okay, so output prefix, key, okay. Binary, and then here this is going to be the IDX make builder, dataset implementation mmap, so that's memory mapped dataset, which means basically your file is on the drive, and only lazily you're just loading the data to your RAM, so you can have huge data sets supported. Make builder. Where is this thing defined? Is it, again, Megatron data index dataset? Okay. We don't have to go into the details of it. And finally, so here is where the generator will be triggered. So now we're going to end up calling this and then acquiring a semaphore and then yielding. Okay, and then read from this LMD reader. What's this? Reader class from LM data format. What's the LM data format package? Let me just double check this. LM data format package. Okay, so this is the guy who I think co-founded Illuthor AI and now works for OpenAI basically. Okay. Okay, let's go back here. So we call stream data on it. Okay, there's just a ton of data there. Acquire and yield, and then encode. So we just encode that piece of text using the tokenizer, the GPT-2 tokenizer basically. That's slow. What's going on? It's not GPT-2 as encoder, it's GPT-2 tokenizer, which is reused across many models. Not sure why, but I'm not sure why people are not training tokenizer more often. Probably compatibility stuff. We are slowly going to wrap this up as soon as we finish with this function, and we can leave it for tomorrow. I said I'm streaming until 11:30 today. That's 15 more minutes, and that has been a long day, guys. 11 hours of streaming today. I mean, I'm just working what I would be doing either way, and I'm just filming myself doing it. So I think it's a fun experiment, and hopefully you guys enjoyed it. Keeps me accountable as well. Thanks a lot, man. Are you in the Discord, by the way, SQ? Thanks a lot, Asim. Aha, you're not in the Discord. Okay, give me a second. So this is my Discord here. I even have a channel where I'm posting details about the streams. So let me just invite you here. Let me copy. There is a new NLP study group, by the way. You should check it out. Brian from my server, who is a moderator, he's an awesome guy, and he's currently together with a couple of folks trying to build a group for just studying together, going through the Stanford NLP course. So if that's something that's interesting to you, do join. And also we have amazing events coming up. Like we have the director of Cohere, of machine learning at Cohere, Niels Reimes, who is like very famous in the embedding model space. He's the author of the Sentence Support paper, etc., and he'll be coming as well beginning of September. We had amazing guests over the previous period, like Trida of the Fast, of the, what's the name? Is it, oh my god, my brain is not working. Fast Attention paper and work. Horace, who is the PyTorch compilers guy. A lot of cool people. Davis from Mosaic ML, so like very cool guests coming up. We'll have Jeremy Howard as well, like over the next months. He said yes, but he's currently busy. Maybe even David Ha, but he's starting his own startup, so again, very busy. We'll see how things go. Do we have a recording? Unfortunately, we did not record Horace's talk, but then we started recording everything else. So we had Aran Komatsuzaki as well. We had the Gorilla authors. all of those are basically filmed. I'm gonna post to YouTube probably over the next couple of days if you find it valuable. I'm not sure why this is not running. For some reason this is stuck. Maybe it says it's running, but it's impossible. It's that slow. Is it running on GPU? I'm not sure. Let's double check. Let's just see this. Nope, I don't see any special activity there. Like, okay, let's just kill this. And let's rerun the process dataset and just disable everything except for this and rerun. Not sure what's going on. Why is it so slow? Let's maybe 0 iterations per second. I mean, it's not moving. Anyhow, guys, I think we can continue this tomorrow. To be honest, maybe let's quickly skim what's going on. So it's gonna encode, get the text IDs. We're gonna append them here. We're going to retrieve that back, and then what? So here we are. We get the bytes processed, the document. We release the semaphore. And then we go through the sentences. We log the progress and we save the final file. Okay. Yeah, I think we can quickly wrap that up even tomorrow. Let me try one more thing. Let's just stop this. And again, let's encode. Let's run this and let's step into this to see what's going on. Okay, let me just step into this. So here is a piece of text, and what's the length? Maybe that's what's problematic. I'm not sure why we are... Oh my god, okay, that makes sense. So it's probably just taking a lot of time, right? Because it has 100 million characters. Okay, guys, that's the thing. It's literally trying to... It's very slow. Okay, as you can see, it's running and running and running and running and finding the tokens. So all is good, it's just, it takes a lot of time, right? Regular. Okay. Makes sense. let it run a little bit. You have an idea why everything in one chunk? Why everything in one chunk? Not really. I mean, we are iterating here, we are looping here, so. Okay, let me let it run. Self-path is just some regex pattern. We can do one thing. We can ask ChatGPT what exactly it's looking for, because it's kind of unyieldy expression, as you can see here. Let's maybe ask. I think ChatGPT is perfect for these use cases. These are what? Contractions for words like is, not, are, have, am, will, and would. Any of these contractions. Okay, makes sense. And then this thing, this part matches a space, optional, followed by one or more Unicode letters, represented by the backslash p open bracket l close bracket, a space followed by one or more Unicode digits. Okay. A space followed by one or more characters that are not white space, letters, or digits. So basically, this is a way to split this, the text into. This is, I think this is just the original OpenAI. If you take a look at the GPT-2 repo, I've seen some similar regex patterns there. So now I kind of recall that. Matches one or more whitespace characters are not followed by a non-white space. Okay, simply matches one or more whitespace characters. Seems to tokenize the text by identifying and separating different types of tokens, including contractions, words, numbers, non-alphanumeric, and whitespace. It is important to note that without the context of how this regex pattern is being used in a larger code or application, its exact purpose and behavior might be clearer. Okay, that actually explains it fairly nicely. Yep. Nice summarization. For those types of like single line, explain me this regex or explain me this bash script line, it's perfect. It literally works very nicely. I love using it for such use cases. I mostly use it as like a Copilot, but a bit differently. Like I use Copilot mostly when I'm generating. I use ChatGPT mostly when I'm analyzing. So in that sense, they are fairly complementary for me personally. Okay, guys, I'm gonna let this run so that we don't have to wait. And then tomorrow we're going to go through a couple more files here. Let me see what else. Get some familiarity with the GPT-NeoX. And then see what's the best way forward. Do we use FairSec? Do we use GPT-NeoX? In that case, we have to re-implement some of the machine translation code, which might be fun. And then we can start running the smaller checkpoints and see, slowly start building up those muscles, and yeah, might be fun. Okay, guys. This is enough for me today. 11 hours, too much. Constantly sitting here and filming and working, so it was very, very, very cool. Thanks, guys. Let me just, by the way, because I don't have the chat included, so I'm gonna just quickly skim through this so people can see what other people asked. Awesome. Ending the stream now. Have a good night. Have a good day, depending where you are, guys. See ya, SQ and SM and everybody else. Cheers, guys. Ending the stream.